Okay, so before I go into the question, let me just tell you two things. There's two formulas that, let's assume this and we can't prove this for now, okay? So formulas. So this is just the first one is just a general kind of algebra formula. Is if you have these things, it's called a determinant. So if you have 3, 2, 1, 4. If you have like numbers arranged in a grid and you have these vertical lines, that's called like we have this notation for a determinant. And the definition is you times the diagonals and you minus the product of the other diagonals. Okay. And we need a 3 by 3 to capture a formula that we need, and the definition for the 3 by 3 determinant is you can take any row or column and do the following process. So let's pretend it's this row. You do 1, 2, and 3 in alternating signs. Yeah, and then okay, so and you times them by these 2 by 2 determinants. Okay, and which 2 by 2 determinant is it? Well, if you're looking at this one, then you delete the row and column that it's on, and it becomes that 2 by 2 determinant. So it's 5, 6, 8, 9. If you're doing the 2, you delete the column and row that it's on, so then you get 4, 6, 7, 9. Okay, so can anyone hazard a guess what the numbers should go in here is?
4, 5, 7, 8.
Yeah, good. Okay, and then obviously by this rule you can figure out what these numbers are, yeah? So here it's 5 times 9 minus 6 times 8 minus 2, 4 times 9 minus 6 times 7 plus 3, 4 times 8 minus 5 times 7. Okay. So that is called the determinant. And it usually comes up when you learn matrices and linear algebra, okay? But we only need just the formula. And another formula, barycentric coordinates now. So what barycentric coordinates is sort of you pretend that there's weights at the vertices of the triangle, and the center of mass of those weights is a point with those coordinates. So for example, if you put 0 weights at B and C and you put 1 kilogram at A, the center of mass of that configuration will just be at A, right? So it's 1, 0, 0 is the coordinates of A. 0, 1, 0 is the coordinates of B, and 0, 0, 1 is the coordinates of C. And of course, you can put, like 1 kilogram at C and 1 kilogram at B, and no kilograms at A, and you'll get the midpoint. So this will be like 0. And then we should scale it so the numbers add up to 1, because obviously if you scale it, you'll get the same center of mass. So instead of having 0, 1, 1, we have 0, half, half. Okay. And if you want to put the other midpoints on it, you can. So this will be half, half, 0, half, 0, half. And basically what we have is we have a formula. The formula I want to write down is for the area of a triangle, okay? So let's take an example. Let's take this as an example triangle. So the area of this triangle, let's call it DEF. So the area of triangle DEF is equal to the area of triangle ABC times the determinant. So think about the general version of this formula. I'm just going to write it for this. So you just put the coordinates of D and F into the determinant. Perhaps in like a clockwise or anti-clockwise order. You might get the wrong sign, but it should get the same number, okay? So DEF, so we have like 0, maybe anti-clockwise then. 0, half, half. That's D. E is half, 0, half. And F is half, half, 0. Okay, so we know from theory that this triangle, which is the midpoints, DEF, should be a quarter of the area of the big triangle, right? So hopefully this thing evaluates to a quarter. So you can see what that is. So for example, if we do the first row again, it'll be 0 minus a half plus a half. Can people just tell me when they've verified that that's equal to a quarter? I'll write a calculation out at the same time. So this one is half, 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 0. This one is half, 0, half, half. So this is minus a half outside of 0 minus a quarter plus a half outside of a quarter minus 0. No. This is 1 on 8 plus 1 on 8. That's 1 on 4. Okay, so basically you need to assume, so the determinant formula, that's the definition. So that's not an assumption, it's just defined that way. Once you define it that way, the area for the triangle in barycentric coordinates is given by the determinant. So that is something we're assuming, okay, without proof. And let's see how it applies to our question. So if you look at this diagram, so the coordinates of A are 1, 0, 0. Coordinates of C are 0, 0, 1. Coordinates of B are 0, 0. So this is picking a reference triangle. Okay. Yeah, so it might seem a bit weird. No, maybe I'll talk a bit about that later. Let's just do this. So Q is the midpoint. So Q we know is 0, half, half. And we know that, so this is completely routine, right? If you think about it, once you know how to do this. So P is in the ratio 3 to 1, so it has 0 in the B coordinate. And if it's closer to A, then it should have more mass at A, right? So so the ratio of the masses is opposite the ratio of the distance. And R, well, we don't really know where R is, but we can kind of make up some pronumerals. We know that it has no C component because it's entirely between A and B. So R is something, something, 0. And we can say it's little r 1 minus r. Okay, so all we have to do now is plug in the area formula for the A, right? So what we get is we get PQR, right? So PQR is this. So PQR, the area of triangle PQR is the triangle ABC times its determinant. R1 minus R0. Okay, and that's supposedly twice the area of BQR, which is so let's keep it anti-clockwise. So yeah, so 0, half, half. So that's Q. 0, 1, 0 is B, and then R is yeah. This is the right diagram. Yeah, I'm using your diagram. Yeah. So are we looking? So this should be enough to solve for R, right? And this should be the final answer. Yeah. So remember, ABC is 300. Okay, so how do we do this? Well, we could take like the top row, for example. So get 3/4 times half, half, 1 minus R0 minus 0 plus 1/4 times 0, half, R, 1 minus R. And let's cancel out the 300s for now. And that's supposedly equal to 2 times, oh, there's a lot of zeros here, that's nice. So we could actually expand down this column, but instead of confusing, let's just keep doing it along this row. So you get 0 minus a half. So 0, 0, R0 plus a half. 0, 1, R, 1 minus R. And let's see. So this gives you 3/4. Half times 0, 0, and minus 1 minus R times a half. Plus 1/4. 0 times 1 minus R is 0. And minus R on 2. And that's equal to, so this determinant is 0. The 2 by 2 here is 0. So it's only the other one that matters. And the 2 times a half cancels, so we're just trying to figure this out. And we just get R, I think, here. Press R. That's very strange. Just get R, yeah? So we know the final answer is going to be 300 times R, right? And here we can solve for R. Do lots of things, but yeah, let's just do it. So times both sides by 8. Um, 3R minus 1 minus R equals 8R. 3R minus 3 minus R equals 8R. Oh, did something go wrong here? Minus. Something's not quite right. What just happened, Phil? Hold on, let's see, 2R. This gives you 6R equals minus 3. Something went wrong. So PQR is twice the area. 30 1/4. 0 half half. And R1 minus R 0. And here it's 0 half half 0 1 0 R1 minus R 0. They should have both been anti-clockwise, so that's fine. Yeah, plus 1/4. 2. It's negative R on 2. Oh, okay. I think I found my mistake. So if you look at this, that should have been a minus R. So this should be a minus R. I get minus 8R here. And this should be minus 10R. Okay, and then R is equal to 3 over 10. So 300R is equal to 90. Yeah. Okay, yeah, sorry, that took a little bit longer, but So that's the preview into the future, okay? So this actually solves the general case of the problem completely routinely. If you think the triangle coordinates are a bit strange, well, so whereas, kind of Cartesian coordinates are like sort of ruler compass geometry coordinates, um barycentric coordinates are kind of like ruler coordinates, okay? So you don't have a compass, so you can't measure the 9 degrees for the x and y axes, but you can draw a triangle. Okay, so barycentric coordinates are the natural coordinates for projective geometry when you learn that later. So no one expects you to be able to do this in this exam, but I kind of just wanted to point out that the questions are vulnerable to all these other advanced techniques as well. Yeah, I mean the marker might not even be aware of this to be able to mark it properly, but I think they've heard of probably Bary enough that they probably can look it up. Um, yeah, so this is the kind of thing that won't be that useful for you in this exam, but I'm hoping that it'll give you a sort of a preview into the future, and you see that we're not just trying to dead end cram for this exam, okay?